Hello and welcome to today's lesson. Our topic today is basic probability concepts, and our learning goal together, again after lesson and completion of homework, you should be able to explain and apply basic probability concepts to real-world applications. All right, so in order for us to go through and talk about probability, we need to have some common grounds here in terms of what terminology or what we're talking about. If we have the same vocab, it allows us to move through this material a little bit quicker. So the first terminology is experiment/simulation, so the words are interchangeable. And this is what we would have, our definition of this is a well-defined process that models an actual event. Actual event. Okay. And our next one is what we call a trial. And the definition of a trial is one repetition of an experiment or simulation. So one repetition of an experiment or simulation. And our outcome is the all possible results of an experiment. So all possible results from an experiment. And finally, event, and that's a subset of our outcomes. So a subset of the outcomes. So that's one particular case of our outcome. So we're looking at a specific outcome, and that's what we would call an event. And the list continues here on the next page. So theoretical probability. So theoretical probability is a calculation of the ratio of number of outcomes that make an event to the total number of possible outcomes. So a calculation of the ratio. So we're going to be dealing with fractions over the next little bit of the number of outcomes that make up an event to the total number of outcomes. Again, remember my philosophy with the course. You're not going to be expected to regurgitate questions like this when it comes to terminology. Probably going to be set up in a matching table. So if it's in a matching table, as long as you can place theoretical probability with the definition and you have a general idea of what the definition is, you'll be fine. Experimental probability is very, very similar. It's a calculation. But this time, it's the ratio of number of outcomes that actually occurred. So a calculation of the ratio of the number of outcomes that occurred. So we're actually counting in this case how many times something happened to the total number of outcomes. We're going to see some examples of this. So if you're having a hard time visualizing this, it's a whole cart and horse situation. I want to throw out the terminology before, and then you see some examples and you realize that the definitions are much, much worse. So what is the formula for probability? Formula for probability is simply this. It's simply, and we use P for probability, of event A occurring. Okay, so our P refers to probability. And the A can be whatever we're analyzing. And it is so from our set notation from the previous unit, the number of ways A can occur divided by how many possible outcomes there were. So it's simply a fraction of one number over the other. So off to the side here, probability of A occurring, N of A, number of ways A can occur, and N of S, total number of outcomes. So unlike the previous unit, there was sometimes when you're trying to figure out how many ways something can occur, and I said, well, there's no real formula. You can use pictures, tree diagrams, etc., etc. Here we have a little bit more structure where probability is number of ways we want something to occur divided by total number of outcomes possible. So we talk about certainty and probability. Certainty is how certain something will happen. And we deal with it in either percentages or decimals. So it could extend from 0 to 1, or it could extend from 0% to 100%. And in here is where we deal with this uncertainty or this chance something will happen. So you deal with this anytime you look at the weather, for example, and you see a percentage of chance for rain. You're dealing with a probability in that particular situation. So most of us have already practical experience with this. Certainty is definitely something that's kind of tough to wrap your head around. The one thing you got to remember, for 100% certainty, it's got to be it's going to happen. So it has to be as sure as the sun will rise tomorrow. All right, that is something that no matter what, you can bank on that happening. If that doesn't happen, well, you don't have to worry about homework tonight because it's kind of the end of the world sort of situation. So the sun will rise tomorrow. You're going to pay taxes, or you go to jail. So some things are certain 100% will happen, 0% happening. What would be a 0% chance of something happening? For example, it could be I can grow feathers. At this point in time of my life, I am pretty sure that there's a 0% chance I can grow feathers. In here, in between, is where our uncertainty lies. So the middle is your 50%. And as you move up and down the scale, as you move to the right, what we say is you're becoming more certain, but not guaranteeing. And when you move the other way down the scale, you're becoming less certain. All right. The one thing I do want to make clear, and this is always a common mistake that I see when I mark tests and that kind of stuff, probability has to be between 0 and 100. Has to be between 0 and 100%. Okay? You can't have more than 110. You can't say that there's a 110% chance the sun will come up. Okay? In the mathematical world, it starts at 0 and ends at 100. So even though you would like to believe you can give 110% out in the ice or on the court, okay, really we're limited numerically by the 0 and the 100. So that's where it starts and that's where it ends. All right. This is where this one ends. The next video we'll do some examples and we'll make the definition seem a lot more clear for those that are still reading it and trying to wrap their head around. And we'll see you later.